Hi folks, this is the cluster API / cluster API AWS code walkthrough session 2 of 5th of October 2021. Previously on walkthroughs, we covered some of the core controllers. We covered the APIs, how conversions work, storage versions, the hub and spoke model. We covered roughly how cluster controllers work, and we were working ourselves through machine deployment, machine set, and then machine. So I think we got to the stage of where machine set templates a machine, an info machine, and a kubeadm config. And I think the next step is we were going to take a look at what happens next. Unless is there any questions from the last video that anyone had? No? All right, I guess we'll get going then. I will share my screen. Is that the right one? That looks right. No, it's not the right one. Oh no, it's right. Cool. Right, so we were lost in the machine set controller, and we got to this clone template model step here. So the machine set is trying to match the number of replicas which are specified in machine set, determines that there isn't sufficient replicas, so therefore it creates a bunch of resources. So the thing it's going to clone the bootstrap template, infrastructure template, and create a machine that goes along with it. And as we saw, the clone template uses the sort of unstructured reader in Kubernetes, so that allows you to not know the specific types. Rather than having CAPI have hard-coded entries for all of the different providers, there's a certain contract that you need to meet, and then and one of those things is you create a resource that you have a resource in your infrastructure provider or your bootstrap or controller which has the ending of template with a capital T, and it will create a copy of that resource and take off the capital T, take off the template even. So it doesn't know the specifics of the infrastructure, it just creates those. So given that the machine set created the sort of the three resources for a machine, the machine itself, the bootstrap, whatever the bootstrap is. In our case, that's going to be the kubeadm config or any consumer of the core cluster API machinery. And in the infrastructure, with at least for my purposes, that's going to be AWS machine, or it's going to be your Azure machine or vSphere machine. I think probably at some point it might be worth the CatV folk doing a thing on their particular infrastructure machine controller, because they've got some interesting behaviors as well. So if you look at CatV, you actually have two resources. You get a vSphere machine, and then you immediately see another resource called the vSphere VM, which is intended to present a sort of EC2 type wrapper, I guess, around the vSphere API. So that one's interesting in itself. And I think they're changing all that. So that's probably worth a session in itself. But so we'll go through the AWS scenario and using the core controllers. So that's kubeadm config and that's it. So the kubeadm config controller. So we'll use that as a bootstrap. So so let's have a look at the machine controller first of all. And I've not looked at this for a very long time, so this is going to be new. All right, so we have, as we covered last week, so we have the controller OneTime registering the functions to create a watch on the API server for resources, and then there's a function to handle what to do with them. So in this case, the machine controller actually does watch on clusters, and it has a function, if you see this cluster to machines, that cluster to, oh yeah, so yeah, it's probably worth going. So there's this util package in cluster API, and that's got a bunch of stuff that's used by not just the core Kubernetes core CAPI controllers, but also the infrastructure providers. So you will see this in Kappa as well. You'll see this in CapRe, CapZ, any other one. So that's if you find yourself doing something with a core cluster API object, then it might be tricky. Likelihood there's code already there. You just need to have a look, find it in the util project, util package. So what this one is, with the cluster to object mapper, I believe. Yeah. So when we create resources in cluster API, we attach a label onto them, which is going to be the cluster name. So that's a static entry. So you see cluster xkto/cluster name. So essentially, the cluster to objects mapper goes through resources in a namespace. Is it in resources namespace? Let's have a look. Yeah, essentially. Yeah. And then we're just looking for resources that match the label. So it's going to do that in the namespace, get everything, I think, because that's what that unstructured list is doing. So that means in this case that if there's a change to a cluster, then the machine controller is going to actually enqueue all of the machines for that cluster. So so you might have seen a bug about that in Kappa, but where it's caused API rate limiting concerns. The reasons we do this is because when you deploy a cluster template, you immediately get a bunch of machines which are not able to be provisioned because the cluster infrastructure, as covered last week, so that's the network infrastructure typically, is not yet ready. So the best way to speed up the creation of the machine immediately after the network is created is to enqueue the machines after a change in state on the cluster resource. So this goes right back to the beginning of cluster API. Like, how do we speed up the creation of the cluster? If we create a watch on changes to cluster state and then queue all the machines immediately, we might need to revisit this again or put some rate limiting or find some mechanism. I know the CapZ folk are also interested in having some sort of limiter as well for but yeah, this potentially can, for the infrastructure providers, it can cause some rate limiting issues. But but at least for the machine controller, it's not a problem, because at this stage we're only talking about the machine controller doesn't understand the infrastructure. It's not going to work with the infrastructure, so it's okay to go ahead and reconcile with the machine. So that's what we're doing here. So if we're doing a normal reconcile, you'll see in every controller a block like this that just return a non-error if the object is not found. So unlikely this would happen, but you could get a situation where a resource is queued up, it immediately hits reconcile, and at the moment it's being reconciled, somebody's deleted it somehow, and then therefore that you don't want to just do an error. So the other thing to note is for controller OneTime, if you return an error, So you return a result. So this result can have a bunch of things. We used to use this a lot in Kappa. Is you can, most people just send a blank result. So when you finish processing, so that means it's not going to get requeued immediately. But you can also say requeue true, and then you can also say I want it after a certain time. So it might be you have an operation that you on the infrastructure side. So for an example, we don't do this in Kappa, but for instance, you could say, well, I know NAT gateway is going to take about a minute. So I could say NAT gateway is not created, I'm not going to return an error, but I am going to say do reconcile after a minute, and then we can check everything again on the AWS cluster controller, for instance. So if you return nothing in the result, that means no requeue. And if you return an error with a blank result, that does mean an immediate requeue. And then that will go through an exponential backoff. Does that make sense in terms of like what the expected requeue behavior is? The other thing you'll see, another interesting thing about controller runtime is this pattern here. Well, not that pattern, that's a bad example. So I think there's this one here. So I've always done this on comments in Kappa as well. So if you just did this, so normally in terms of Go, this is totally fine, right? You should be able to just do that. However, the problem with this, at least in the current version of controller runtime, is if you're looking at the logs for the controller, the error that you'll see will be you won't see the log, you won't see the file line basically. So you will just see controller runtime controller.go in that other repo with the error, and you won't know where it's come from. So the way around that is if you log here, if you do the logging at this step before the return, then at least you will get a duplicate error printed in the logs, but at least we also get the exact point that error happened. And that has been super useful in Kappa, at least, especially when it's like I say AWS like rate SDK error or something that's come from EC2. If you just see that on the controller runtime controller go, you might not even know like what action, what resource, what was actually happening, what API call was actually being attempted. But at least if we have it just before the return, then that's okay. The other thing is this controller from logger from context, by default, it's going to have the name of the namespace of the resource, the kind of the resource, and the name of the resource being reconciled in the log line. So from a debugging aspect, that's super helpful as well, because you know exactly what's being reconciled, and you can do things like with values, so you can append information to this as well. So I think I don't know if I did it in Kubadium control plane. So it's slight off tangent, but considering debugging is a lot of our lives, it's probably worth covering. Yeah, so you can do things like you can put key values. I didn't merge it. We didn't get it merged in, I think. So what you can do is you can start appending information. So you can do log with values, need rollout. Oh. You could do that. And then that means every time you now use this logger, it's always going to have these values attached, which can be super helpful. And say we were to have, say something like Elasticsearch, like an ELK stack, then you could potentially index on all of these things. I know there's argument not to use indexes on logs now, but nowadays, but it is there as an option. I don't know if there's some attempt to fix all this in controller runtime to fix all the logging issues so that we actually get proper log information. I think that there's been some changes upstream in Klog to allow you to traverse up the stack. Controller runtime is not using that version of Klog yet. So potentially we can make a change to controller runtime in a future release where we actually just, when we log at that level, the error, we can say, look back down the Go stack from the callee or from the returnee and print that as the line number and file. So if in a future release, we might be able to fix this in controller runtime, but certainly not for V1 Beta 1. So I think this is very much V1 controller runtime V011 because it's a breaking change to the logging libraries, and all the consuming controllers have to change it. And there's probably an action item to follow that up with an issue in the CR repo. Yeah, so tangent on that, I will just not remove these changes. Let's go back to machine controller. Yeah, definitely use it if you're debugging, if you're like going through a bug like temporarily, instead of using like printing out to STD out, use the log grid values. That's my tip. Okay, so yes, so the next thing is if the machine belongs to a cluster, add an owner reference. So how does that one work? If R should adopt, what's that one do? Let's have a look. Get controller of nil has owner. Oh, okay. So I think, yeah. So what's happening here, I believe, is there's the reconcile. I've lost my place now. Close that. Close that. Close that. Oh yeah, because in the reconcile, so one of the enqueue functions is it will always find the cluster that belongs to the machine going by the label. So all this is saying is we also want to set an owner reference on the machine that it belongs to the cluster. That then allows you, if you delete the cluster, to then have the delete propagated downwards. So that's what that is doing. Phases. Did we cover phases last week?
I don't think so.
Yeah, no. So phases were a mistake, I think, broadly speaking. So this goes all the way back to cluster API V1 Alpha 1. So the V1 Alpha 1 design was based upon pods, as we went last week, pods, replica sets, deployments, at redeployments. So it was based on that. Pods have phases, but and so do replica sets, I believe, have phases, and I think deployments do. But if you look at the newer ones, like stateful set or daemon set, they don't have phases at all. And there's reason for that. They don't work as a thing. So there's probably...
I also linked the documentation in the API conventions about this deprecation stuff. zum Chat.
Yeah, so the problem with phases is it's all very well, like you might, in the early days of Kubernetes or early days of Cluster API, I have a machine, I turn it on, it's ready, it's running, I've terminated it. But then someone goes, hold on, there's this other thing that might happen. And how do you represent that? And then also states are not, they're not single dimensional. Then, so like a phase is just one string, but it might be that in the pod, it's classic example, right? The pod is running, or a node is a classic example. So node is not ready, but why isn't it ready? Well, node is not ready because it's insufficient RAM, or CNI is not working, or it's run out of disk space. And maybe for some of those cases, I don't care. So CNI is not ready, but that doesn't mean I can't run a pod with host networking. So we moved away from in Kubernetes in general, we moved away from the idea of using phases to using conditions instead, because conditions allow you to say this specific thing is true or not. And it's up to me or the consumer to decide what action I want to take, depending on that particular thing. The problem with phases is that the phases it ended up being like a sort of aggregate of different conditions that might make sense for one infrastructure, but doesn't make sense for another infrastructure. So for AWS, for instance, you can turn off machines without destroying them, or you can do the same in vSphere. There isn't a phase that represents that in Cluster API. And we already introduced conditions. We didn't want to add it. So we kind of hack it in Kappa. So Kappa marks the machine as we abuse the phase essentially in Kappa, and we break the contract deliberately, because you're not supposed to be able to move from running to not ready. It was always only intended to be a one-way direction, but we deliberately broke that in Kappa just to make it work with phases. So at some point we probably need to remove these. That's I guess. But there you go. So use conditions is key to that one. Yeah, and you can see it doesn't do much. There's not a lot happening in the machine controller. It sets a controller reference, writes a phase, and that's about it.
This one, but like line number 239 should adopt, right? The comment says that the machine belongs to a cluster, add an owner reference.
Yeah.
So should adopt actually checks this cluster CR and then adds the owner reference.
It already has. So the reconcile. So if we go back to the NQ bit, go back up to the top. So we're doing the watching clusters. Where's the one for the machines itself?
I'm wondering, it's like should adopt is something that decides whether it should put an owner reference or not. Like
yeah, it only decides that. So by the time, so the reconciler will always try and grab a cluster for a machine going by the label. So the cluster name label.
Mm-hmm.
So by the time you're already in this reconcile function, so you've already got the util get cluster by name.
Got it. Yeah.
From the yeah, so you so it just takes. Oh, sorry, it's on the machine spec. Sorry, the cluster name is on the spec. There is also a label, but it's also on the spec. So there's a cluster name on the spec. So the reconcile function is going to grab a cluster resource anyway. Then it goes into reconcile with the, so we got the usual stuff around, is there a deletion timestamp? If there is, do a delete. But then we go in reconcile, and this is a common pattern you'll see in all of the providers, that you always pass in the relevant cluster resource anyway. So once you're in there, all this is saying is set an owner reference if there isn't one. And probably I suspect that this should, because it's kind of a, don't know what the language of that should adopt, I think might be stemming from v1 alpha 1 to v1 alpha 2 upgrade. So we used to use API aggregation service before CRDs, because CRDs weren't ready when we started cluster API. So I think some of the terminology in terms, at least the functions, might be referring to work that happened to adopt v1 alpha 1 non-CRDs and actually adopt them as v1 alpha 2 CRDs. It was actually you couldn't do that with conversion webhooks. You had to run a separate tool to be able to rewrite the resources. It was completely different. Was it even controller runtime? It was basically almost a complete rewrite. So I think some of that, the terminology of the function names comes from that, I suspect. Okay, so there's not a lot that happens in the reconcile normal, just sets a owner reference, and then we set some phases. So I think if we take a look at that, so we reconcile some of the, okay, so we do a bit more. So we've got the reconcile bootstrap. So what do we do here? So we so the machine controller is mostly introspecting the related resources and machines. So if we go back to the machine resource, we've got the look in wrong directory. Yeah, so we've got the bootstrap ref and our infrastructure ref. So the machine controller isn't doing anything particular, but it is going to introspect those resources and then mark conditions on the machine itself. So it's going to look at the we'll be more clear once we go into what the bootstrap controller does. So the we'll come back to that in a minute. So the bootstrap controller is going to edit the machine and set a data secret, which is going to say where should the information for bootstrapping the machine come from. Once that's filled, the machine controller considers that as bootstrap being ready. So it's not introspecting the bootstrap resource directly, but it's expecting the bootstrap resource to do something to the machine, and then based on that considers whether or not the machine is at a particular state. Yeah, and then we got the reconcile external. Let's check that one. And what do we have to check? Okay, so we've got some handling to handle old versions of resources. That's fairly new, I think. So I think this is to do with v1 alpha 3 to alpha 4 upgrades. Yeah, so I think that we need to, inside the, if we go back, move that. Yeah. We have a look at that. So we've got the infrastructure ref, we have the API version and the client. So that API version, so if you upgrade from v1 alpha 3 to v1 alpha 4 or v1 alpha 3 to v1 beta 1, the infrastructure ref stays the same in the machine because it's part of the spec. So the top level API version changed, but the the strings inside the rest have not changed, I believe. So then this will rewrite that API version to the latest version, say v1 beta1. Then we we'll yeah, I think that's it. Is there anything else that's happening? What else is happening? Yeah, I've not looked at this for a while. Got a bunch of stuff for. Oh, I'm not even sure. We're doing.
It's also like related to something like migration.
Yeah, that's
Yeah.
true. I mean, yeah, all of this is, I think. Oh, are we checking the resources exist? Yeah, I don't know. That's might have to come back to that at some point. I'll make a look at look in more detail. I think I might need to come back to that one myself. We've got reconcile infrastructure, and we've got that reconcile external again. Yeah, so this is handling the case where, say someone's deleted, at least on Azure or AWS, someone's deleted a machine. So they might have done this either by deleting the AWS machine on the Kubernetes cluster or Azure machine or whatever it is on the Kubernetes side, or they might have gone on to the infrastructure, say EC2, and hit delete. And Kappa might have said, well, this machine's been deleted, so I'm going to now delete the machine as well. Then the machine controller needs to handle that state as well. So maybe so we then need to fail the machine. So we don't, one of the things is we don't automatically, without machine health checks, we do not remove resources ourselves. So you actually need to go. So even if a machine has been deleted from the infrastructure side, you do need to go and manually clean up yourself. And that's deliberate because we want to tell the user something has happened. Because it would be extra weird where if you automatically remove resources, so if someone does an operation, you've got a Kubernetes cluster, it's all running successfully, it stopped working because somebody's deleted the machines on vSphere or Cat-V, and then you look at the management cluster and it's empty. I'm like, what was that? What's happened to my cluster? Like, it was there a minute ago. So instead, you mark machines as failed and explicitly tell the user to clean up.
So at this stage, we only just provide the information by marking false and stuff like that, and we do not actually bring up the machines automatically. Like
we never replace a machine.
Okay.
So you can't, if you have a machine, so just like pods, you can't have a pod might restart on the same host, crash loop back off, etc. But you're never going to have the pod rescheduled to a different node.
Right.
And have it one there. It has to be recreated. Likewise, in Cluster API, if there's a machine and for some reason the info machine has gone away or whatever, you don't go and create another info machine for that same machine resource.
But the machine on the infrastructure, for example, on the cloud provider, does it get created again? I mean, not the resource, but machine also is not created.
Yeah. You have to delete the machine to get a new machine from the machine set. So delete the machine, let the machine set see there's insufficient replicas and do that. So what has happened is the machine health check stuff. So the machine health check controller can come and delete the machines for you, but an infrastructure provider should never recreate an infra machine for the same machine. Should never have duplicates, essentially.
Yeah, makes sense.
Yeah, so then we're checking, and we have this condition set mirror. So this set mirror bit is, if I'm a third party tool, and yeah, I will mention one right now since we can, Tansy Community Edition. So you're running Tansy Community Edition. Logic in that code base, I mean, there is a lot of if you go and look at that, if you go and look at those repos, there is a lot of infrastructure specific stuff in there, but in terms of the cluster API side, it's infrastructure agnostic. So those toolings and say another product like Tansy Mission Control or something like that, or maybe EKS to some extent, if they're monitoring infrastructure resources, they don't specifically want to write infrastructure specific code into all of their projects. So the idea here is they only have to look at the machine resource and the machine status to find out the status of the infrastructure. But we need to get some information from the infrastructure over to the machine. So Cappy has code to introspect the machine, the infrastructure machine's configuration and the status, and copy those conditions across. So there is not, I don't think it's everything though. So it will be, yeah, so it's only the infrastructure ready. So it's only, if you need more information, like something specific has happened about a particular infrastructure, then you still need to go down to the infrastructure resource. But to get basic information around what's happening in infrastructure, Cappy will copy at least the infrastructure ready condition. And there's been debates around like how much information should be copied. Some people have different ideas. It's always a fun one. Any questions on that? All right, cool. And so delete is the more is kind of interesting. So we need to do some more stuff here. So when we delete a machine, the machine controller is actually really interested in this. So there's a couple of things. What we don't want to do is you're running your I don't know, you're rendering next episode of Mandalorian in your AWS cluster on your NVIDIA grid job. You know, it's taking 45 minutes to render a frame. For some reason, somebody wants cluster autoscalers coming in, said actually some other rendering job is finished, so we can scale down this cluster. And this machine that is still sitting there rendering this frame of Mandalorian gets killed. And suddenly that work is lost. That job needs to be rescheduled. That's time and money. You know, that could be $5 maybe just wasted because the machine's been killed. So we need to do something with that. And that's where we have the node draining behavior to move workloads, to ensure that Kubernetes is moving the workload around before we actually delete the machine on the infrastructure. So there is an ability to mark machines. So say for this job that can't be terminated, then there is an ability to mark the machine as I thought we had a reference, maybe not. Oh, maybe we do need one. So I thought that's the use case. Okay. So we can only delete a machine if there is a is that right? Yeah, if the cluster return it early if the cluster has been deleted. Is delete allowed? How does that work? I think I know why it's like that. Let me just check.
because the delete is already in progress in
Yeah, I
background.
think, well, I think the other issue is, so one of the things we found was that if you don't order everything correctly, and well, I think the easiest use case, if you take AWS, for instance, you start deleting the cluster, you start deleting AWS cluster, your load balancer is gone for the API server. So there's absolutely nothing you can do to drain the node, because you're not even going to be able to reach the API server of that cluster. So at that point, like, you might as well just give up. It's like the clusters, you're deleting everything. So why do you care? You're saying everything should go. So just screw it. I don't know. There might be a use case where someone wants to create a cluster for a particular job and have it killed only after that job is finished. No one said that yet, but then there might be in the future someone wants to do that. But the standard behavior is, if the cluster's being deleted, we think everything is going away. Therefore, we don't care. We're not going to drain. Just delete all of the things. Yeah, we can't delete something. So yeah, we'll come back to NodeRef controller. We'll probably need to cover that. Node reference controller. That's the wrong doc, isn't it? That one. What? Yeah, so if there isn't a node in the machine status, then we can't, there's nothing we can drain. And if it's a control plane machine, then we're not going to, well, hold on. So skip this. What's special about external control plane?
Not managed by Cappy.
Oh, I think it's similarly. Yeah, I think similarly for external control plane, if we're in the process of deleting the external control plane, like we're not going to be able to do anything. I think that's what that is. And finally, why would we do that? Get filtered machines cluster. I do remember this function. Oh yeah. Yeah, and then we've got some special handling of the control plane, number of control planes. Can't remember this. I do remember. Well, I do remember this, but don't remember why. I think control plane machines might not have a node reference. I think for some, I think when you're starting up control, well, can't remember. I don't know actually. Don't know.
No, at least I have seen in control planes there is no reference.
Yeah, but they don't start off with one
Okay.
because their CPI might not be running and bits and pieces. So I'm not sure. I don't understand that. I'm sure there's a reason. Right. So if we're doing, all right, there's a bunch of conditions basically. If those conditions are met, we start draining the node. There's a couple of ones where we do not drain the node. You probably needs to look through. So for that, I think there's essentially what we have is a bunch of code that is copied from somewhere else. We stole some code, basically, because I think it was in a core Kubernetes repo, and it really shouldn't be, but we don't have a choice. Yeah, so we're using this third-party modules. Where did we steal it from? Yeah, so it came from Kubernetes KK. So we never import KK into the project. So this is a special case. This code, for some reason, does not live anywhere else. It's only in kubectl. And everyone has copied it. So we've also copied it. And so we have a copy of the drain code library in cluster API. It's in KOps, I think. It's in everywhere. All of them have a copy of this code. No one's thought about moving it to a library.
With the disclaimer of the copy.
Yeah. No, and people have thought about moving it to a library, I think, but I don't think there was any consensus about where to move it to. So it's there. Yeah, so we do a bunch of node draining. So for a node drain specifically, I used to remember what this did. So we ignore all daemon sets. You can't. A daemon set necessarily runs on all the machines, so you're not going to drain it. It's usually CNI anyway. Okay, so we cordon the nodes so that the kube scheduler doesn't put new pods on it, and then we run the node drain, which as far as I remember, yeah, it deletes all the pods, and after a certain timeout, I think it will then evict them. Yeah, so there's a bunch of timeout stuff. And I'm surprised that people have not asked for more options around this. I'm surprised because both KOps and the Cloud Foundry Container OneTime have got quite a few options around node drain behavior. So that's interesting.
Stephen is saying that we could now use the node drain as a module, but
yeah, we had an issue in Class API for a while, and apparently with 122 we now have a drain code in kubectl with context. So I think maybe now we can use it.
Oh yeah, and there's a bunch of specifically vSphere specific. Well, it's not vSphere specific, but it's mostly for vSphere. If you're using on-prem stuff with storage attached networks and stuff, there is some special handling you need to do with volumes. vSphere is no exception in that area. So we need to do some special handling for volumes. I think that means we don't want to start deleting pods before. We don't want to start deleting nodes before the volumes have been removed, because otherwise the CSI controllers get hung up on them, and the volumes don't get moved. I don't know if that's. I've seen it come up often enough that we've got that code in Cappy, and people mention it in various SIG cluster lifecycle stuff. So assume it's wider than just vSphere, but it certainly is something that affects the vSphere CSI. Yeah, so that's the machine controller mostly. I think that's mostly what that's doing. There is a NodeRef controller. So I've never looked at this one actually. I just assume it works. So there's a reconciler that watches. Well, let me tell it. Does it maintain? And that's one bit I've not. Oh, okay. So we got this reconcile. Okay, it's happening in there. Interesting. Yeah. So. I forget who sets provider IDs now. Who is
what that code here? I always thought this code here retrieves the provider ID from the node and sets it on the machine.
Yeah, so it is retrieving from. So how does it match the node with the machine?
Okay. Obviously not that way around. It takes it from the machine.
So is the infrastructure provider filling in provider ID?
Oh,
I
yeah.
think so. Yes.
Yeah, should so. Should.
Yeah,
Otherwise,
sorry,
the nodes
yes.
are also not getting ready without a provider ID.
Yes. So the infrastructure provider, is that right? I guess so.
Yeah, I know there's also a hack in CapD. So in CapD is doing it because there is no cloud controller to do it. But I think the node lifecycle controller, it's usually called in the cloud controller.
Yes, that's right.
The stuff on the node.
So we'll come to that when we actually go through what a machine is actually doing through Bootstrap. But at some point, it's also going to have a provider ID on its own NodeRef. So Cluster API takes no role in setting the provider ID in the node. That's completely delegated to the cloud controller manager or external cloud provider integration. Infrastructure controllers do set the provider ID on the, did they set on the infra? Did they set it directly in? I think they set it directly. They must be setting it directly in the machine spec provider ID. And then from that, we can match a node with a machine. So that's how we match, because often, especially with the cloud providers, if you create a machine, the machine, you don't know ahead of time what IP address it's going to be. You don't know what its ID is going to be at all. So you create the resource, then the infrastructure provider tells you this is what the machine's ID. I created a machine with this ID. This is what it is. From that, the infrastructure provider should be calculating a provider ID that matches the cloud provider integration, stores it back on the provider ID. Then the machine controller is actually going to watch. Then we're watching so we've got this remote client. So this remote client, this R tracker get client allows you to get a client for a remote cluster. So any workload cluster. We'll then look at the nodes and find a matching provider ID. And once we've got those two bits of information, we know that this particular node on the workload cluster belongs to this machine. And that's the only way. So if we have a node which has completely different provider ID, we don't have any machines that have that provider ID in the spec, then as far as it's from Cabby's concerned, it's like we don't know what this machine is, what this node is. It's just going to be there, and Cabby's never going to touch it. Likewise, if we created a machine with a provider ID and we never see a node with the same provider ID, then your best guess is Bootstrap has failed, and that's when you start looking at the machine. But yeah, if it's not Cabby's responsibility to set node provider ID is the key point.
So this provider ID is generated by the provider controller. Okay.
It's on the machine spec provider ID is generated by the infrastructure provider.
Okay, got it. Yeah, line 53.
Indirectly. So I looked at a code. I'm not sure if you already mentioned it. So it looks like on the infrastructure machine, you have a spec provider ID. And
okay.
The machine controller in machine controller faces.go, it takes it from the infra machine and sets it on the machine. So it moves it up.
Right. So it's another instance where we copy information from an infrastructure provider. So the infrastructure provider doesn't set it on the machine, it sets it. So infra machine controller copies the provider ID up.
So
from infra machine.
The physical node that actually gets created, does that has a trace of this provider ID somewhere?
No, it needs to calculate it again for itself.
Okay, so for a particular physical node, the calculation always returns a unique provider ID.
Oh, for a physical node, well, depends what you mean by physical node. So for
maybe some examples would help.
Yeah, so I don't know what's a good example.
So usually it's something like a full qualified string, which just describes the machine. In OpenStack, it's just a UUID. I think in AWS and Azure, it's some kind of
so
AWS and
it's
then
like
the region.
EU West 1 is I dot, yeah, that. So it's the Is it? I can't. What I can't remember if it's kubelet or cloud controller manager. It's cloud controller manager.
It should be, it's, as far as I know, it's cloud controller manager who sets
Yeah.
it. That's the question. I know in OpenStack it is, so I assume it's, or at least when you're using, I mean, everyone is using now external cloud controllers, I think.
Yeah, it definitely is.
Then it should be
so
there, I
AWS
guess.
isn't, Azure isn't using
Okay.
external. So
okay, yeah. If we don't
we
have
have
one,
a
then
cloud controller manager, which might be for Azure and AWS, the in-tree one. For vSphere and everyone else, it's running as an out of tree. It's running on the control plane. So your kubelet registers. So at least in the AWS case, against API server as usually something like that, 10. Like it's a version of the IP address. I forget the details exactly. It's something like that. EC2 dot internal, something bizarre like that. The controller manager then needs to convert this into a provider ID. So the kubelet registers, it just has a kubeADM token or something, or some credentials. It says to API server, please give me a certificate. And I can prove I'm allowed to have a certificate because I have a set of credentials. So API server, so certificate signing request stored on the API server. Controller manager then signs the request. Well, no, it doesn't. Today, kubeADM says it's okay to sign. So there's a bunch. This is interesting from a security perspective. So in today's world, kubeADM authorizes the certificate, and then controller manager hands out a certificate.
that sounds bad.
It is bad, and the reason for that is because kubeADM is infrastructure agnostic. Because we don't really have a good way of identifying a machine otherwise. But
so the storyline is that using this provider ID, we could actually potentially identify a node uniquely.
yes. And there is a proposal about how to not authorize the certificates before you've got the provider ID and done some guarantees around. Because the other reason is, right, so we now need to convert this IP address essentially into a provider ID. So what the cloud controller is going to do EC2 dot describe instances, filter IP, DNS name equals that EC2 to CCM goes, okay, that's that instance ID. CCM to API server, set NodeRef, set node.status of, and it knows it's AWS. It knows which region it's in. Done that. If we were to secure the authentication process, we want to do a bit more than this, because we might. The problem with this is I could be any rando. All I have to say is, as long as I've got a kubeADM token, I can say I am that machine. Like I haven't proved. There's no proof of that. So because the kubeADM token can be used to register as any machine. So I can still register as a different machine as long as it already exists. And I will still get that same node thing. And I might then at that point say I'm the control plane and get access to things that I shouldn't do. So it's pretty bad. So there is a proposal where we do some other things. So when we do the kubelet registration, there's like a challenge prompt basically. You need to but the kubelet needs to register as API server with that plus proof of identity from AWS.
Right.
So there are mechanisms for each of the cloud providers to say, can you, please give me a signed document or signed statement that says I am this machine.
Right.
And then we can issue a certificate for that. But that's not gonna, it has to be infrastructure specific.
Yeah.
So it might be for vSphere vSphere can use TPM, GKE does use TPM. So there are ways to do it. So there's like specific certificate for GKE that you can use to verify you can, it's already in GKE as well. So the kubelet will do a challenge response against the TPM device, store that, and then the cloud controller manager verifies their TPM attestation and gives out the certificate at the end of that. So that's already working GCP. EKS likewise does things a bit differently. It registers against API server as its name, but with credentials that prove its identity. So it no, actually it doesn't do that. So I think it does get, I've forgotten exactly what it does. It does some of the things that we just talked about, but it also has its own login flow as well, where it will authenticate with AWS, get that to prove its identity, create a signed statement, and only then get a Kubernetes token to then register. So there's no kubeadm in the mix, which is kind of what we want to do anyway. So we want to remove kubeadm from registering machines because it's not safe from a security perspective.
Yeah. Thank you.
Yeah, and then reconcile interruptible node label. I've not even heard of this one. What is this one? This is new. Is it new? That's it. Have a look. A year ago, newish. I think this is to do with cluster autoscaler as well. I think this is the idea that you might have nodes where you don't care about the workloads on there. So it's like the opposite of I'm rendering the frame of Mandalorian that takes 45 minutes and it's costing me money. It's the opposite. Is like I literally, this is just something I'm running for a joke, or like it's a batch workload. I don't care. So please just delete the machine. So I think that's the idea. I think.
Yeah, that's the name suggest, interruptible.
Yeah. I think it has a special meaning in the cluster autoscaler. I did see some stuff around it. Yeah, so that's I think that is pretty much the machine controller. So we're doing nodrain, remove the finalizer at the end, and once you remove the finalizer, that's it, it's gone from the cluster. So that's the machine controller. What time is it? 1:08. So we've got 20 minutes. Are there any questions? I don't think we've got a time to do a whole other controller today.
So far looks good. Need to revisit also.
Sorry, what was that?
No, I said so far looks good. You know, I need to revisit also to digest all of these things.
So do I. I mean, there's bits in there that I'm not super familiar with, to be honest. But it's not a controller that I think with a lot of, like I don't interact with it much. I don't often have to do anything with it. Yeah, so yeah, be interesting. Let's have a look at this interruptible. Someone must have. I'm intrigued by it now. There must have been an issue about it.
Oops.
Have Have I spelled that right?
Stop it.
No? Oh, okay. Oh no, wrong repo. That's my fault.
Oh yeah, it was on your personal.
There you go. That would have been weird. Yeah. Okay, it's to do with spot instances. Right, different. So interruptible, in this case, is to do with spot instances. So it's the use case where a machine might be terminated by the infrastructure provider for random reasons, well, cost reasons.
Okay.
And that requires special handling. I think one of them, yeah, so let's have a look. So it's that old classic conversation around moving labels around that we've been having. There we go.
I think maybe you can put this on chat.
Yeah, probably. Yeah. Yeah, so they're talking about things. Some of this stuff is old. So they're talking about this daemon set that runs on each spot instance. I've kind of suggested that isn't necessary anymore. They've got a PR to update this, I believe, which but I'm kind of questioning some of it now. So they mentioned this daemon set that needs to run all the machines that then spots if a machine is going to be interrupted. Yeah, so yeah, so if you they're talking about this one, the AWS Node termination handler. So it's actually changed quite dramatically from what they've been talking about. So it's gonna so traditionally the machine, it's the way this worked is there would be a daemon set on the machine that then looks at a special HTTP endpoint that says, am I being terminated or not? But there is a whole other way to do that, where you can have it as a controller that then monitors a queue of events, which is what their recommended model is. And we already have support for this in Kappa. We just haven't, no one's used it. So we have this queue processor. So yeah, I don't know the specific. I think this is, I'm not really familiar. So it's to do with batch jobs, but I'm not sure the exact case. Does anyone else know? I don't know. Yeah. Something to do with workloads that I think it's still to do with workloads you don't care too much about it, which is why you're running them on spot instances anyway, because they're cheaper. But they can be terminated at any time. Yeah, so I reckon it's to do with putting labels on them such that another controller can preferentially pick them to be deleted, or machine health check can come in and do something around it. I think that's what's that about. But yeah, have we documented any of this? This is the other interesting thing. So no. So cool. We've got, yeah, I think there's probably, if someone wants to give it a go, I'm sure there is definitely a follow-up issue to start documenting some of our annotations, some of our supported annotations. yeah, I've definitely spoken to support staff within VMware who are like, oh, I want to do this thing. It's like, oh, just use this annotation. It's like, what? And they've been like, what? So, oh, it's been there for 2 years now. It's like, so there's probably something we need to do there. I think one of the issues is as a project is we've got quite a bit of documentation stuck in proposals. They only exist there, and we need to start percolating some of this stuff up into the book. So I think that might be, I think there's probably an issue here that we should do. I've lost my docs, I'll stop sharing a sec. Yeah. Whilst that, I'm trying to sort that out. Any other questions?
Yeah, I had one that I'm not sure whether it relates to cluster API or not, but I was just wondering, like when we were saying that controller watches a resource, like let's say machine, and we have enqueued a lot of machines. Like you were giving an example that we have an issue with API rate limiting. So if a lot of machines are there in the queue, and there is it like all the controllers are processed parallelly, and is there any thread pool kind of stuff there to limit the number of reconciliations?
Yes, there is. Yeah. Hold on. I can show you that. So all of the controllers, and including ones that implementers should have on their main. If you look at main.go, I'm probably looking, it's not there. So, right, so we have these values here: cluster concurrency, machine set concurrency. So those are your thread pools, so to speak. So you will only get 10 by default. Does that answer your question?
Okay, yeah. So is there any anything we should keep in mind while writing controllers? Because we have like multiple controllers running for the same kind of job. So is there any example we have got in cluster API where this creates a problem? Just curious.
What do you mean multiple controllers for the same job?
I mean, like what we are doing is, let's say we got 10 machines and 10 controllers are running, and for each machine, and they are trying to query some other resource like EC2.
Oh,
And
right, yeah.
EC2 has some limits that kind of. Is there any problem that we face due to this?
Yes, there is. There definitely is. So it's not perfect, and we still have problems with it. But what we have done in AWS, if I can find it, is no, that's the wrong place. Is it that one? Yeah, here we go. Right, so we've only handled this at the AWS level, and it's not perfect. But what we have today is this needs to be revised a bit. Actually, we need to do it on. Yeah, so the AWS SDK allows us to add. We can essentially add our own functions at various lifecycle events of the AWS request. So for instance, we capture metrics for Prometheus, but one of those things is we push in a service limiter. So we have a service limiter thing in this throttle library that allows us to match on EC2 API calls, like the strings. So we do have this, I have it coded somewhere, like an example. Where have I done that? There we go. Right. Yeah, so we have this service limiter that allows us to, so we create a bucket. We have some ability to burst all the so that's handled at the SDK level, but I don't know how well the SDK does that per. Oh no, it doesn't. So this we create this at the, where do we create? I think we create this in main.go. We should be, at least. So this should be the same rate limiter across all of the concurrent operations, and then any of those will decrease the value of the bucket by a certain amount, and then they will get refilled at a certain amount. So the way that works for AWS is that read operations, you can do a fair amount of it. So that's 20 per second, but you can only create 2 machines at once. So that's how that works. So that should work as the rate limiter. And then we have some additional logic that says if we get told by AWS that we are being rate limited, then stop everything. But it might not be working completely, so we might need to revisit that. But it's helped a bit. Sorry, it's I think the worst affected are AWS, because AWS rate limits are pretty bad. And vSphere isn't rate limited, but you can easily DDoS the, well, not even DDoS, you can easily denial of service attack the vCenter from CatV if you get into a loop that bad, because CatV will just, it can easily just do try and do like 1,000 requests in one go. And that can be pretty bad.
Maybe when we do scale testing, these things will come.
Yeah, so scale testing puts it up, and the and there are changes coming for people who are using vSphere that who are watching this. There's work coming to introduce similar concepts in vSphere. So any other questions? Does that make sense? Sorry, that's
yeah, thanks. That totally makes sense.
Yeah, I'm not sure how well it's working though, given that issue. So might need to do some testing around that. That code was essentially copied from another AWS project. So it was originally written by AWS themselves. We just copied it in with their blessing.
Yeah, got it. So actually, I was more like wanted to know that since multiple threads are working for same controller, so it's like you said that EC2 service or some core services which have to interact with any third party, they have a singleton kind of approach to handle that.
Yeah, it's not so much a singleton, but at least it's a singleton throttling mechanism. Yeah, so the throttling is done as a singleton, and
yeah,
I can't remember. I did write this, so I copied it and then copied it. Hopefully I did put a mutex around it and all kinds of stuff. I think I did. Maybe I didn't. Maybe that's why it doesn't work. Oh, I think I'm using what? So there's there is a rate limiting package inside Go itself, but I don't think it worked. Yeah, so we have a synchronization. Yeah, there we go. So there we go. Yeah, so there's a bunch of mutexes. So that's how that works. So that's why it is shared across all of the reconciler workers.
Got it. Yeah. Thanks.
Oh, I'm not even sharing screen. Sorry. I'll just show that again. So it's this one. So we have this Yeah, it's based on the Go one, but it's not quite the same. I added some extra features that I wanted to it, but yeah, so we got this mutex. Right. Anything else? Or all right. I think we'll call it then. I'm not around next week, so I think next session will be in 2 weeks. All right. Enjoy KubeCon, folks.
Thank you, Nader.
See ya.
See you.
Bye.
Bye-bye.
Thank you. Bye.
Bye bye. Thank you.
Yes,
Thank you.
bye.
Bye.